Today we're going to take a look at how we can persist the player's loadout where it has a small file size, but we still have that full loadout support like what we see in games like Call of Duty and Battlefield. Hey, Chris here from LlamAcademy, here to help you.
Who, me?
Yes, you! Make your game dev dreams become a reality by helping you persist data effectively. And just a quick note, at the bottom of the video, each segment of this video is cut up into chapters, so you can quickly find the area that you're most interested in. That's on all of my videos. In this one, if you're looking just for the save and load part, there's going to be a part where we start covering stuff that you're probably not very interested in, because this is part 14 of the gun series, and we want to make a complete system as part of this video. Like right now, we already have an attachment screen that works okay for a single gun. What we're going to do in this video is update that screen so it doesn't come up when we press escape anymore. And before we spawn into the game, we're going to have an option to play or customize our loadout. Then we'll go over to that loadout screen, be able to configure which gun should we spawn with and what's the loadout configuration for that particular gun. Then whenever we leave that page, we're going to save that data to the disk. So the next time we enter play mode or run the build, we'll be able to load that configuration. So whenever we go to the loadout page, it'll already have that information. And if we don't go to the loadout page, if we just click play, or respawn with that exact same configuration. And there's really two components of the save that are really important. First, because we're using scriptable object-based configurations for our guns, we don't have to store the whole configuration of what does this gun look like. We can just store the gun scriptable object instance ID of the base gun, and then the attachments we'd like to apply. I'm going to use the index of each attachment for each slot as what we're going to store. So that keeps our file size very small and still gives us the full loadout support. That's pretty cool. Second, we're going to store this data at application persistent data path, which is supported on most platforms, but not all. And I covered a while ago how to save and load data using the JSON data format, which is basically what we're going to do in this video as well. We're going to do it a little bit differently and in a more simplified way, but if you want to see more at the end, I'll link to that video as well. It's really all we're doing. Let's hop into the refactor of our UI toolkit so we can start selecting different guns and that kind of stuff. So far, we have this loadout screen that we built with UI Toolkit. It shows us our gun. We have some options that show up per slot. In play mode, if we press escape, we have the barrel, handle, and ammo type slots. Let's increase our resolution. But this doesn't persist the data, so every time we play the game, we lose our loadout. Let's go ahead and leave play mode, select our UI document, and rename it to loadout screen. Duplicate it and call it main menu. We'll remove the document controller, and we're going to create a new UI document, which really probably should be in our UI folder. That's right-click, create UI toolkit, UI document. We'll just call that main menu. I'm actually going to bring the loadout attachment document in our root styles over there as well. If we open up the main menu, I like to set the hierarchy to look like a reasonable size. So let's do 1920 by 1080. We need to add that existing style sheet so we can use any of the classes we've already created. For the top left style sheets, we'll just say add existing USS and select those root styles. And we just move those to resources, UI, root styles. We'll add an empty visual element. I don't know, maybe call it root. We want to fill the whole screen, so if we add flex grow, it takes up the entire size. That just adds flex grow 1, flex shrink 0. For the background, let's give it a color. This dark gray should be okay. And on margin and padding, let's add something like a 20% padding left and right. Cool. Let's add 2 buttons as a child of that root element. Okay, so they're very small and aligned top. That's probably not good. Maybe make them centered. On the root style, maybe, justify content center. And on this one button, maybe we'll just give it a little bit of margin bottom, make them be spaced out. Yeah, and let's give them both font size of 48. The top one, let's make it say play. If we click this, we'll just enter into the scene. The other one we'll call loadout and give both of these those names of play and loadout respectively. So the intention here is if we click loadout, it'll take us to that loadout screen. If we click play, it'll take us into the game. If we open up our attachment document, There's a little bit of work to be done here as well, because we want to be able to dynamically adjust what gun we're customizing. So we can set up, I want to use a Glock or a M4 or whatever. So I think what I'm going to do is add a new visual element as a container for our icon. So it's grouped together, and we can add maybe like a drop-down selector just to make it easy. You'd probably want to do something a little bit more visually appealing than this, but this is the basic functionality. We just remove the label and give this the name gun selector. We'll populate the values based on the gun selector available gun scriptable objects. Everything else has names, and we already get most of this on the attachment document controller, so I think we're okay there. This gives us the bones of what we need for us to have a main menu on this page where we can select our loadout and then click play to enter into the game, but we can still move in stuff while this menu is open. So I'm going to disable the player armature that has all the player stuff. So we're probably going to need to do a little bit of refactoring here, and also the main canvas. We'll enable those whenever we click play. That means we need a script for our main menu. Let's go ahead and create one of those in our demo UI folder. Call it MainMenuController. Make sure it's in the right namespace. It's going to require that UI document, just like the attachment document controller. And we need some references because whenever we click play, we want to enable those things like the game object, the UI canvas, and we're also going to want to be able to interact with the attachment controller. On awake, we'll get a reference to that UI document, which means we want to cache that reference. And since we have two different UI documents, a really convenient way that we can toggle which one's in front is by the sorting order. So if we set the sorting order to be 2, this one will show up first. We're going to need a couple references to what's on the UI document, like the root visual element, the play button, and the loadout button. So we'll query for root on the document root visual element by name, root. We'll add the visible class. That way we can fade out later. We'll get references to play and loadout buttons. And we'll want some callbacks on these whenever we click them to do something. We'll come back to the play button on clicked. For loadout, we can swap the sorting order so it shows up behind the loadout page, and then show the attachment controller, which is currently a private function. So if we hop over to the attachment controller, show and hide need to be public. If we just take a look at that, in the main menu, let's attach that main menu controller, hook up the player object, the UI canvas, and the attachment document. The main menu should have the main menu source asset as well. If we click play, now if we click, nothing happens because the player armature is disabled. We have the two buttons. We click loadout, great. This one comes into play. We can click on stuff, but we haven't populated our dynamic list, and our gun still doesn't change. And we press the X, we bring back here, but the mouse disappears. So there's a little bit more refactoring we need to do. And escape also brings it back. Let's hop back to the attachment document controller. On update, this is where escape is captured. So let's go ahead and just remove that. We don't want this functionality anymore. Well, I think the most important thing that we do here is actually save. Maybe whenever we leave the page would be a good time to save it. So the user can make all kinds of changes. Whenever they're like, hey, I'm done, then we can save. So hide is our exit point where we're leaving the page. We're going to want to save the loadout at that time. But how do we do saving? All I can say, it definitely shouldn't happen here. This should be the entry point to saving, but the saving should be handled by a different class. So we need a new script. We'll put it in guns persistence. We're going to make an IDataService interface and a JsonDataService that will implement that interface. Implementing the IDataService allows us to change out the implementation of how we save, so we're not only bound to JsonDataService. And that allows us to very easily do that in a decoupled way from our attachment document controller or wherever else we decide we need to save and load. We'll start with the IDataService. In here, we'll define a bool save data that accepts some type argument, where we'll also accept a relative path and some data that will return true if we successfully saved and false if we didn't. We'll also define a load data that accepts a type argument and returns that type that only accepts the relative path. That's really all we need to do in the IDataService. In our JsonDataService, we'll make it implement the IDataService, implement these two. In save data, the first thing we'll do is get a path based on that relative path at the application persistent data path. The application persistent data path is a safe place that we can write data to on almost any platform. There are some limitations. Then we'll do a try catch, where if we run into any problem at all, we're just going to log an error saying that we were unable to save that data due to, and then the message in the stack trace, and return false. In the main try block, we're going to check if this path exists. If it does, we'll just log that, hey, this exists. We're going to delete it and then write again. So then we do file.delete at that path, which will delete the file. I'll just do a quick else saying, hey, we're going to write this for the first time if the file does not exist. Then doing using file stream equals file.create, that will create a new file and give us a file stream. There's a more convenient way to write to the file than using the stream. So I'm just going to immediately close that file stream and then do file.write all text to that path. And the contents will be JsonUtility.toJSON, providing the data, and then we'll return true. Now, if you watch my other video, you'll know that I complained a lot about JSON utility, and you might be like,
Chris, why using JSON utility here?
Well, because we're going to be storing scriptable objects, it's much more convenient to use JSON utility because it only stores the instance ID. You can technically do this with Newtonsoft JSON as well, but you have to do a lot more code. So it's just much more convenient to use JSON utility in this use case. Since scriptable objects are static for your build, as long as we provide the base gun scriptable object, we're only storing the instance ID for the gun. We also need to store the attachments, which can be simply an array of integers about which index of attachments we're using. This keeps our file size very small and very simple. We can do basically the inverse of this on load. In the load data, we'll do the same thing, get the path based on the application persistent data path plus the relative path. We'll just check if that file does not exist. If it doesn't exist, we'll just log an error and throw a file not found exception. If we don't throw that exception, we'll do a try catch. In the catch, we'll just log that error saying that we failed to load the data due to, and then whatever error it gave us, and we're going to throw an exception again. In the try block, we'll do T, our type parameter, data equals JSON utility from JSON, saying we want to read all the text at that path, providing file.readAllText at that path as a JSON that we want to read. When that deserializes properly, we'll return it. If there's any error, we'll throw that exception. And again, we're using JSON utility, so we get that instance ID reference. So whenever we get that scriptable object, it's going to actually be the scriptable object, and we didn't have to persist the entire structure of the scriptable object. That's really awesome. But we're going to need to be able to store both a scriptable object and the attachments. So we need a model that we will persist. So in our persistence folder, we'll make a new folder called model. Then we'll make a new class called Loadout that will be the model that we persist on the disk. If we open that up, we'll mark this new class as system.serializable. This will only have two fields, a public gun scriptable object, gun, and a public int array attachments, where the attachments will be an ordered array by the slot. The index is going to be really important, where 0 is the barrel, 1 is the handle, and 2 is the ammo. Now that we have an ability to save and load in our AttachmentDocumentController, where we have all of our variables, we're going to add a new IDataService, and we're going to set it just to be a JsonDataService. Here on hide, we'll make a new loadout, saying the gun scriptable object to be the gun selector active base gun, which we're going to need to make public. And we'll set the attachments to a new integer array with the selected attachments at barrel, handle, and ammo in that order. Over in the player gun selector, we're going to make the active base gun public with a field serialized field, public get, and a private set. That way we can read it back in our attachment document controller, but we can never set it from another class. Once we have this loadout, we'll do if DataService.SaveData, providing a path like /player Loadout.json and providing the loadout as the data we want to save. If that returns true, we'll just log we were successfully able to save that player's loadout. Else, we'll log an error saying we were unable to do that. Since we're going to need to be able to load this data, I'm going to move this player Loadout.json to be a static string. Now we've persisted it, we'll want to be able to load it. Thinking start is a good place for this before we do all of this other stuff. So we'll start at the top, just with a try catch. We'll load the loadout with loadout equals DataService.loadData of type loadout and provide that save file path. If there's any issues loading, we'll go into that catch and we'll pick up that gun because the gun selector, we reference it a lot in this class already. So making sure it has the right base gun is really important. If for any reason we get an error, we'll just log a warning saying that we weren't able to load the loadout. It's not really an error because we can just use the default loadout instead. If we ran into an issue picking up the gun, we're going to pick up the first gun. That way we're guaranteed to have some gun picked up already. Because we're going to try to pick up the gun and our player gun selector hasn't done start, I think we need to do a couple of things. In despawn active gun, it assumes that active gun already exists, but potentially we haven't used one because previously on start, we were guaranteed to have one because we did setup gun and active gun and all this was already set. Let's check if that's not null. So in our gun selector, I'm going to change this guns list to be public so we can read which gun scriptable objects exist. We need to hook up the animator and player IK because awake is not called, the player is disabled. So if we just serialize it and in the scene view, just hook up that player IK, player animator. Now I think we can test this out. Let's go ahead and select some attachments. And we see that we successfully saved the player loadout. In the editor, this is saved at this path, and you can find the player loadout JSON file there. We can see that we have very little data stored here. It's actually 50 bytes, which is pretty good. It just has the gun, the instance ID, and then the attachments of 121. Pretty convenient. Now, if I restart the game, enter play mode again, whenever we hit start, we'll see that it correctly loaded the loadout, and it has our Glock gun, the first one in our gun selector list. And it's actually the reference to that gun. It's got all the stuff hooked up and we can see the instance ID is the same as what we saw a second ago because it's the exact same scriptable object that we have persisted in our project. That's pretty amazing. All of this with 50 bytes of data. Everything else we're going to do from this point on is going to be about refactoring what we have to make this work nicely, show stuff on the loadout page and allow us to dynamically swap between different guns. We worked out the save and load, but our UI doesn't really work right. If we hop back to Unity and click play, we can move over to the loadout screen, but it's showing us the wrong gun. Our dropdown doesn't have anything. And even though we may load some attachments for the loadout, it doesn't show that on the UI. So we're going to address this in 3 different parts. First is going to be the ability to go back and forth on these menus and get the main menu actually working. Second, we're going to get this dropdown working. And third, we're going to show the loadout on the UI based on whatever we loaded. Okay, first things first, whenever we change visibility, we're going to want to raise an event so we can handle properly the sorting order to bring that main menu back in front. To do that, I like to use a delegate function. We'll make a new public delegate void visibility event and 2 public events, visibility event on show and 1 on hide. We'll then refactor our public bool is visible to use a backing field. So we'll serialize a private bool underscore is visible and make our get return that underscore is visible. And our set will first check if the value is true, meaning we are setting is visible to be true. If that is the case, we'll call on show. If that's false, meaning we're setting it to be invisible, we'll call on hide. And finally, we'll set the is visible value based on whatever is provided. If we scroll down to hide, we have some stuff about getting the cursor to be gone. And that's just an artifact of how we used to have the menu working, so we can safely delete this. And I think for the visibility part, that's all we need to do in here. So we can hop over to the MainMenuController, which now on start should listen to those visibility events. So on hide, we'll add a new delegate function that just sets the document sorting order to be 2. And on show, we'll set it to be 0. Remember, 2 means it's on top, 0 means it's going to be behind. We should also make it where we click play, it actually lets us play. On click, we will fade out our root visual element by adding a class list hidden and removing visible. We'll make sure we can't click on it anymore by doing picking mode ignore. And then the order is really important for these next 2 lines that we want to enable the player game object and then again call hide on attachment controller. Calling hide on attachment controller is going to do all the things about configuring our gun for us. So if we click play immediately without going to loadout screen, we still need to call this hide because that's what applies the attachment configuration to our gun and also picks up the gun. It's really important we set the player object to be active first because there's a lot of stuff that happens on awake and start of some of these scripts that we need to happen before we go and apply whatever happens in the attachment document controller. The last couple of things is just showing the UI canvas that has our ammo and our crosshair and hiding that cursor again. So we're just going to set the lock state to be locked and the cursor to be visible false so we don't see the mouse while we're playing and shooting. In the player gun selector right now, on start, we do some stuff about picking a gun. We're doing that all in the attachment document controller now. So it probably makes sense to add a new bool initialize on start, and then in start, if that's set to false, we'll just not do any of the other stuff that we do on start. If it's set to true, then we'll still do all that stuff. That way we have both flows still enabled where we can have this UI, or we can just immediately jump in based on whatever we have configured in the scene. So now we should be able to click loadout, see whatever's going on here, press the X, come back, and again, click play, and we should spawn in with whatever was configured. So that looks good. It gives us the Glock because the Glock is the default gun. So the main menu looks like it's working now. Cool. Let's move on to getting this drop down to work and to change guns based on what we have selected. That means we're going to start in the attachment document controller. And I'm just looking at start. It's a pretty big function. We're going to want to do some more stuff here as well to set up that drop down. So what I'm going to do is start refactoring what's in here to move out a bunch of methods so we can very easily tell what's going on without having to figure out what each of these segments is doing. So our loading of the gun, let's just extract that to a private void load player loadout. The next thing is it's going to find all those UXML references and then set up some dynamic configurations. So let's go ahead and take the second part to a private void set up dynamic fields. Let's find all the elements we need. We don't have references yet to our gun name or the icon or the dropdown. So back up at the top, we have some fields like the scroll view, visual elements, this kind of stuff. Farther down, we find an options container kind of ad hoc. Let's go ahead and just find that at the beginning now. So we just find everything all up front. For the new fields, that's a private label, gun name, a private visual element, gun icon, and a private dropdown field, dropdown. Back down and start. We can do the border left, querying the root visual element on the document by name, border left. We'll do the same thing for the option container by name, option container. We'll find the option scroll view as a child of the options container, just searching for the scroll view. The gun icon, querying for the icon name. And gun name, looking for gun name. We can then take all of this to a new private void setup UXML references. We can also find the dropdown by name and dropdown field type with root visual element, Q, dropdown field, gun selector. Now we do some stuff later on looking for border left in the option container, so we can start refactoring that. In build options for slot, we query for option container, we don't need that anymore. And if we just rename this first to the same name as what we have on the class, we can just delete this line and we're good to go. Border left, we also don't have to check because we always do that on start. Option scroll view, we don't need to query for anymore, so we'll always just clear it. On this back button, we do hide option container. Providing the options container, we don't really need to pass that anymore because it's already on the class. Looks like I should have just named this option container, so I'm going to go ahead and rename that. It looks like that's all that we need to do from a refactoring start position. Now we have this set up dynamic fields. We'll come back to these in the third section where we're going to set up all of that dynamically based on the loadout. But for now, our dropdown, we need to set up what are the available choices and what happens when we change them. We'll set the dropdown choices to be gunSelector.guns, where we're going to convert every gun scriptable object to a string with gun arrow gun.name. We'll then assign a gun name to be either the first gun in our gun selector or the active gun's name. So we'll check if gunSelector.activeGun is null. If it is null, we're just going to pick that first gun, which will be the Glock in this particular case. Else, the gunSelector.activeGun.name, we'll use that. We'll then call a function that we'll define in just a second called setGunNameAndIcon, providing the gun name and an empty string for the second argument. We're going to use this exact same function whenever we change the value of the dropdown, just so we don't have to copy paste code. That'll make more sense once we get there. Just go with me for now. We'll then register a callback on the dropdown for a change event of type string and tell it that we want to call a function that we will define in just 1 second, handle change gun. Finally, we'll set the dropdown value with dropdown.setValueWithoutNotify, providing the gun name. Let's start with the handle change gun. We'll make that private void handle change gun that accepts a change event of type string, change event. We'll get the old gun and new gun values with change event.previous value and change event.new value respectively. And then we'll call that set gun name and icon, providing the new gun and then the old gun. So you'll see that's exactly the same as what we did up here, but in this case, we didn't have a previous value. So we're gonna have to handle that case in this set gun name and icon. Let's go ahead and define that as private void set gun name and icon, accepting the new and old gun names. First thing we'll do is set the gun name text to be the new gun. Then we'll check if that old gun was provided. If it was, meaning not string is null or empty, then we're going to remove that from the class list, because remember that our icons are tied to a class that's based on the gun name in all lowercase without spaces, replacing the spaces with hyphens. So we want to remove the previously selected gun class name and then add the new gun class name, following the exact same pattern we just did. Let's hop back to the Unity editor and click play. Now we see that Glock icon shows up. We've got the Glock. If we click the assault rifle, we see that comes in on the icon. If we press X and click play, oops, I don't spawn in with my right gun. I still have the Glock. That's where we're going to enter into that third segment. We're going to apply those modifiers that we got from the loadout and make sure whenever we hide this UI, we're going to spawn into the game with the right stuff. This is probably everyone's biggest question is, why didn't we spawn with the right gun? Well, remember, hide is what we're calling to apply all the changes that the user selected on this page. On hide, we're going to need to do more than just apply modifiers. We're going to actually need to pick up that gun first. So in hide, we'll find out what is a selected gun with string selected gun name equals gun name.text, because remember we set that as soon as we change the gun selection in the dropdown. We'll then find that gun scriptable object by name with gun scriptable object selected gun equals gunSelector.guns.find, providing a delegate of gun arrow gun.name equals the selected gun name. We'll then pick up that gun and then apply the modifiers. We also don't need toggle input handlers anymore. That should let us pick up the right gun, make sure we save the right gun, because the active base gun is going to change once we pick it up. Now for the coolest part, setting up the UI based on what is saved already. So whenever we call setup dynamic fields, what we can do is get a reference to the attachment that's currently selected. And we can do that with mock attachments for the slot, so the barrel. And then the second part, we want to know which attachment should we be looking at, which we have the index of stored in selected attachments. So we can index by selected attachments, index by slot.barrel. Then our barrel slot, instead of using all this default stuff, we can populate it based on the actual attachment. And for the icon name, we do the same thing as we did with the gun name, making it B2 lower and replacing the spaces with hyphens. And we can just repeat that process for each slot. Just setting attachment to be a new mock attachment at the handle slot. And then whenever we create the new attachment slot with the handle slot, we're going to make sure that we're using this new attachment values and do the exact same thing for ammo. And make sure you don't have any copy paste issues like what I have here. We want to make sure we're using the ammo slot as that last one. One thing we may want to do, because maybe our guns are like at different levels and you don't have all the attachments automatically unlocked, is whenever we change the gun, we reset all the attachments. And maybe also make that UI go away for the attachments, so you have to bring it back out. So to reset the attachments, the first thing we want to do is reset the UI, which we already have a function for, clear slot selected classes. We can then set up our barrel, handle, and ammo slots with that default value. Make sure that we reset our selected attachments dictionary. And finally, we also need to reset our mock attachments dictionary. We can iterate over all the key value pairs in the mock attachments. Set index 0, which is our standard, to be marked as isSelected true, and go over all the rest of them and set isSelected to be false. The last thing I promised before we're ready to test this out, once we've loaded the loadout, we can pick up the gun, but it's also really important that we set up the AttachmentDocumentController selected items to reflect that loadout. Right now we're picking up the gun, but the UI will never represent whatever's on that loadout. That comes in two parts. First, we set the selected attachments dictionary, with the barrel being the attachment of attachments indexed by 0, with the handle being attachments indexed by 1, and the ammo to be the attachments indexed by 2. That's why it was really important that we used the correct order when saving these. We're basically doing the inverse of what we did on hide down here. The second part is our mock attachments need to also reflect what is selected. So we can iterate over all the key value pairs, then iterate over all of the attachments on each of these, and set isSelected to be whether selected attachments at the same key is selected. Now we should be good to go. If we come back to Unity and click play, on the loadout screen, we can see we should get explosive rounds. We should have the long barrel and enhanced grip, so reduced spread and longer time to reach max bullet spread. If we click play, what the heck? Explosive rounds still don't work. Don't worry, we don't have a bug. On our player armature, we made a long time ago this gun modifier applier, and we actually don't want that to be active anymore. If we disable that, click play, now our explosive rounds work. Pretty cool. Just for fun, and to make sure everything works, if we restart, go to the loadout, click frost rounds, and nothing else. Play again. We get that frost effect. And of course, our save file is still just the gun instance ID of whatever that gun scriptable object is, and our attachments are aligned exactly to what we selected, still right at 50 bytes. It took us a while to get there because we had to do this change to the UI Toolkit to make sure that we could change guns and rebuild the UI based on our saved loadout, and that took a little bit of time. The core of what we did here was just persist that gun scriptable object instance ID and the attachment configuration, and then apply those whenever we load into the game. You could take this a step further to persist the loadout per gun, and whenever the player swaps from Glock to M4 or whatever, you load that loadout from that gun and then rebuild the UI like what we just did, so you don't have to reselect all the stuff each time. That'd be a really good challenge to solidify your understanding of what we've done in this video. And if you got value out of this video or the series and you want to support the channel, I'd really appreciate it if you use the affiliate links in the description that link to the asset store and Humble Bundle. Clicking through those helps me out a lot. It doesn't cost you anything. That's really, really helpful for me. And if you want to show your support directly, you can go to patreon.com/LlamAcademy or just click join or super thanks right here on YouTube. You can get your name up here on the screen, help drive the direction of the channel with monthly topic polls, and some other cool perks too. At the phenomenal tier, there's Andrew Bowen. At tremendous tier, there's Bruno Bozic. At the awesome tier, there's Autumn K, Ivan, Rulin, Iffy Obelisk, Solar Int, and Perry. There's also all of these great supporters as well. Thank you all for your support. I am so incredibly grateful.